Hello, welcome to Math 1960, Section 301. This is UNO Summer Session number 3. In today's lecture, we're going to discuss about the tangent line. We want to find an equation of the tangent line at a point on a curve. So we want to know about what is a smooth curve. A smooth curve, if dx over dt and dy over dt are continuous and are never simultaneously zero on interval a and b, then we call this curve a smooth curve. How do we find the slope of the tangent line on the smooth curve? Dy over dx is equal to dy over dt over dx over dt. So to find the equation of a tangent line using those parametric equation at once. So first of all, we say dy over dx is going to be equals to dy over dt over dx over dt. The dy over dt here is going to be equals to 2 dx over dt here is going to be 6t, and then when we substitute for 1, we're going to get 1/3. So at this time x is going to be equals to, we substitute for 1, x is going to be 3, y is going to be equals to 2, so then y minus 2 is equal to 1/3 x minus 3. So then we say y is equals to x over 3 plus 1. That's the equation. We want to find all the points on the curve at which the tangent line is vertical. So when the tangent line is vertical, that means this here is going to be equal to 0. This is going to be equal to 0. And then if this is equal to 0, that means dx over dt, which is equal to at this point 6t is equal to 0. That means t is equal to 0. When t is equal to 0, that means y is equal to 0 and x is equal to 0. So this is the point where the tangent line is vertical. So we want to find the slope and prove that the slope is equal to that. So first dy over dx, it's equals to, so we're going to find the derivative of this over the derivative of that. So the derivative of this is going to be equals to sine, it's going to be a sine t, and the derivative of this is going to be equals to a times 1 minus cosine t. So a and a cancels out. To find all the point of the cycloid where it is horizontal. So it's horizontal at that time. This one is going, the numerator is going to be equal to 0. Then we prove this right now. We proved it. So it's going to be horizontal. That means sine t is equal to 0. So what is the sine is going to be equal to 0 when t, because it's between 0 and 2 pi, so it's going to be when t is equal to pi. So that at this time a is x is equal to a pi, and then y is equal to 2a at that point. So that is the point. Find the point. So the point where it is horizontal is this point. Find the equation of the tangent line to the cycloid when it's horizontal. So when it's horizontal, we say y is equal to 2a. That is so we want to find the equation of the cycloid. So first of all, we want to express dy over dx, so dy over dx at this point, it's going to be equal to v naught sine theta minus gt over v naught cosine theta. So express the slope of the tangent line to the motion of the product. So this is the slope. Right now we want to find when t is the is maximum. Well, when so at maximum this one here, the equation has to be equal to 0, or the upper part of the equation has to be equal to 0. So that means v naught sine theta minus gt is equal to 0. And then at this time we say t is equal to v naught sine theta over t. This is at what time? This is the time at which the projectile is at its maximum. So at maximum height, that mean the so-called the equation has to be equals to 0, or it's got to be flat at maximum.